Hello, we are Team 8 and we are proud to present a course decision tool that we are developing for Anne Blanford and the Institute of Healthcare Engineering. I am Sami, Team 8's leader, client liaison and systems architect.
Hi, I'm Zikun Yang, decision tool designer, implementer, and tester.
The problem that we're trying to solve is that many prospective students in the IHE are unsure about which course to choose due to courses having a lot of content overlap between them and having names that sound superficially similar, as shown on the screen. There are also other subtle differences between the courses, such as the fact that some are accredited by some organizations while others are not, which could be important to some of the prospective students. Our solution is to create a course decision tool in the form of a website in order to help the students identify the most suitable course for them and highlight the key differences between the courses. We have chosen to implement the decision tool as a website for two key reasons, which are accessibility and familiarity. A website is very accessible as most prospective students will have a web-enabled device and many people are familiar with using the internet. In order for our project to be successful, we have conducted a lot of research in order to create a set of useful requirements. In order to conduct our research, we firstly interviewed some lecturers in order to find out if there are any activities or modules unique to their courses. Next, we sent out a questionnaire to many current UCL students to identify the key factors that informed their decision to select their current course. We chose to use a questionnaire as this form of data gathering can scale particularly quickly, allowing us to gather data from many prospective students simultaneously. The slide demonstrates the Moscow list we created as a result of our research. We prioritized the key features in our must list, such as having a questionnaire to obtain the students' data and providing a drop-down selection for the users to submit their answers. This was very useful as it acted as a checklist during our coding stage to make sure that we remained focused on the most important functionality. To finalize our list, we presented it to our client, Anne Blanford, to make sure that she was okay with it, and then started coding once she gave us the green light. Before we started coding, we thought of the functionality and key algorithms that would be used to make the program a success. After considering these, we chose to use React as our front end of the website. This is because the framework would completely eliminate the need to have a backend, as it provides all the features needed to create a rich UI, as well as having all the functionality to complete our algorithms. We deemed this to be good for our project, as the lack of a backend could speed up our development and productivity. Our next step was creating a systems diagram to plan out how we would design our website. We went into quite a lot of detail, specifically focusing on how to structure the classes to maintain good coding standards. For example, we tried to keep the home page as the root of truth, containing all of the state of the program and controlling the data flow to other classes. We decided to have two display classes, one to show the questions and one to display the final results. We chose to separate these two out to make the program more modular and easier to test. This allowed us to then work on them separately and improve the speed at which we finished the prototype. We also created our own separate data fetcher class to handle the data manipulation independently, but I'll come back to this topic during the last slide.
The sitemap shows our current website design, which separated many of the different UI elements into their own separate classes in order to make the code more modular and easier to maintain. This would also allow us to reuse any classes, such as ensuring the same footer appears in each page. To give a brief overview of the site, it starts off by rendering the question page as well as the header and the footer. Since the user has not inputted anything yet, the question page class returns a render of the question class, which basically presents the question form to the users. The users can then fill all the answers to each of the questions, and the program will store the responses as part of the internal state of the question page class. Once the user presses the submit button, the question page class then switches to return a render of results class. In this class, we basically filter the courses based on what the user has inputted, and we access the user's choices through props. Finally, there is a back button on this page, which causes the state of the program to be cleared, and causes the result page class to switch back to the question page class. This is a link to our current prototype. We have deployed the website to Azure. We are proud to see that we have already completed a lot of the functionality that is listed on our Moscow requirements. We made sure to try and implement the must-haves before the other requirements to ensure that we had the most important features implemented first. As the image demonstrates, The website does present a questionnaire. We allow users to submit answers through the drop-down menu, ensuring that they do not type in any answers. Our first question is the most important one and does not allow the user to submit without answering the question. We also make sure to include a question on the predicted grades, which is used in our filter system. As the Moscow list states, we are not forced to answer any other questions and can submit blanks, which takes us to a list of matching courses. We also provided the back button functionality, which allows the user to go back and change their answers.
One of our biggest concerns right now is that we are actually operating on our own dummy data that we created. This is because we have still not gotten access to UCL's database of courses. We are starting to hit a bottleneck, as the next stage we have to improve is our filter algorithm and ranking algorithm, which is heavily reliant on knowing the type and form of data that we're going to obtain from the database. Once we have done that, we would then start adding more questions and filters to improve the accuracy of our decision tool. We will then enter our testing stage. This will be split into two parts. Firstly, we're going to build technical tests to make sure that our program is working properly and that the filters are doing what they're supposed to do. The second part would be acceptance tests, which would involve presenting our work to current IHE students and getting their feedback on what we have done. This step is essential, as our iterative agile approach requires us to speak with users in order to see if there are any improvements we can make for our next prototype. Also, we would like to add a section to allow the users to directly compare two different courses. This would basically outline key differences such as the different modules, but again, we cannot start this until we get access to UCL's database. Thank you for watching our project.